properties of graphs using our Ti-Nspire CX. So for today's video, I'll be considering a quadratic function, which is x squared plus 19x plus 34. So now what we'll see is how to analyze this graph, using our graphs. So if you clearly see, our graph is, first thing is the graph is not visible in the screen at all. So what I'll do, I'll go to menu. So there are two ways of doing it. One is adjusting your window settings, and another is using our zoom in and zoom out. So I'll explain you both the process. So let's go with first. Now since the graph is out of the screen, right, it's not visible, so I need to zoom out. So I'll go to menu, window and zoom out. So I'll go to here and I'll zoom out, right? So now this is my graph, which is x squared plus 19x plus 34. Now sometimes what happens is, okay, this particular our zoom in and zoom out feature, this usually makes the scale as uniform, in the sense I cannot adjust my x-axis and y-axis when I'm using my zoom in and zoom out feature. Now how to do the other way around? So I'll go to again Windows and zoom. So let's go back to the same thing. So this was zoom standard, this is how the graph was. So I'll go to menu, I'll go to window settings, and I'll adjust my window accordingly. So x minimum, x maximum. So how much minimum x values do you want? Now since it is not visible right now, so I'll, let's say, go for minus 30, and x max 10 is fine. It's not a problem because your positive one of the roots is visible. That means the right hand side root. Now y minimum, I'll go for, let's take minus 50 and 50. So I'm just taking values accordingly. All right, now my roots are, roots or where my graph cuts the x-axis are visible. However, my vertex, the or the minimum value is not visible. So that means I need to adjust my minimum value again. So I'll go to graph window zoom, window settings, and y minimum I'll reduce it further. So for I think my 70 will do. Yeah, and I can keep this a little this side. So now our graph is clearly visible in the screen, or that means in the window. Now let's try to see what all our Ti-Nspire can give us. So first thing is, let's say, how do we know the solutions? So I can go to analyze graph and zeros. So select the lower bound, so you will get a line like this. Tap it, okay, cross the point, and so that's my first solution. It means minus 17, 0. Second solution, again, analyze graph 0, 2, which is minus 2, 0. Now let's say if you are interested in your minimum value, I can go to again menu, analyze graph, minimum, same thing, tap it to the left, pass the point, which you are interested to cover, again tap it, which is minus 9.5, comma minus 56.3. Now let's say you want to see the values on certain things, you can go for graph trace, and you see this particular comes, and it gives you what are the function values for certain x values. So let's say it's minus 17. I want to know, let's say, what's the value for let's say minus 16 something or minus 18 something. So minus 18 is 16. So it covers the integer values in certain cases, sometimes it doesn't. So but it just gives you an overall idea how your y values and are changing with regard to the x values. So you can find out using this. And also the another way is go to menu, table, you can see a split screen table. So what is the value for 1, 2, 3, and for 0 it is 34, which is your y intercept, and I can go up So minus 17 is 0, which is one of the roots, and minus 2 is also 0, which is one of the roots. Again, this is also, your integer values, and it gives you what is the value of f of x for that particular x which is being written here. So I can close it again, menu, table, sorry, escape, come here again, menu, table, remove table. Okay, now let's say you have another line here. Okay, let's say I want to insert another line. So again, press tab, and let's say my line is y is equal to 2x plus 1, right? Now this is another line, and it intersects my parabola at 2 points. Okay, one is at this point, another is at this point, and let's say we are interested in knowing what are these intersection points. So again, go to menu and analyze graph, intersection. So again, select the lower bound. Okay, that means the lower bound means the values, you have to take a value which is previous to the value you are interested in calculating. So I want to know this value, so my lower bound has to be anywhere, okay, wherever you want. So tap it and then pass it, and again this, so which is minus 14.8 comma minus 28.5. Again I can do intersection, this, pass it, and I can calculate. The another one is minus 2.24 comma minus 3.47. So in this way you can know what are your intersecting points if you have two graphs are given to you. So this method works, it doesn't need not necessary only for quadratic, it works for cubic, exponential, or whichever the two graphs, and they intersect each other. So these are the basic things which we can know about a parabola using our Ti-Nspire. So one is the roots, then your minimum value, maximum values. Okay, depend upon if your a was negative, then we had an inverted parabola, so that's the maximum value. We can know where your if there's in case there's another graph and they intersect, so what are the coordinates of that intersection point. Similarly, we can use our table, okay, to know the values for the integer values, whatever f of x has, if x is any integer value from that table, we can do that. So we'll be going, I'll be uploading further more videos regarding our Ti-Nspire, and more in detail about what more we can do using graphs of different types, maybe cubic or exponential or trigonometric. All right, till then, take care and have a good day.